All right, hello. Today we are going to solve some inverse trig equations that have transformations in them using no calculator. And we are going to try and do it to find the general solution, which would give us a way to describe all the angles that are solutions, and then find some particular solutions on a given interval. So before we start, let's take a quick look. I want you to try and remember or see if you have memorized your inverse trig formulas. So for all solutions, right now you should be starting to get them in your head. You should for sure know how they work, and at best you should have these formulas memorized. So I'd like you to pause the video and see if you can fill in your note sheet right here, and if not, then you can keep listening if you don't have a clue. But please try and pause and fill this in. And hopefully now you're back, and let's see how you did. So when we're talking about cosine of theta is A, if A is positive, one solution is right here, right? This is going to be my cosine inverse. If A is positive, cosine inverse is this angle right there, okay? So then another solution, if A is positive, is going to be right down here. If the ratio is positive, I have these two quadrants, and right there is my negative inverse cosine of A. Okay? If my ratio, when I get a negative ratio, so when A is negative, inverse cosine gives me the answer between 90 and 180. So here is my inverse cosine of A. And then the other solution would be down in this quadrant, which is negative cosine inverse of A. So for example, if my inverse cosine gave me 60, another answer is negative 60 or 300. If inverse cosine gave me 120, another answer would be negative 120, otherwise known as 240. All right, and it works the same in radians. So for degrees, it's plus and minus inverse cosine, and then the plus 360n, what that does is it says, well, if I have an answer right here, there's another solution 360 degrees away. All right, and if we're in radians, it's the same idea. It's still plus and minus inverse cosine, but then we would add 2 pi instead of 360. Now for sine, if A is positive, if we have a positive ratio, again, we're right here. So here's my sine inverse of A is going to be right there. Now in this case, my other solution is over here, right? And if I think about this being theta, then this angle is 180 minus that theta, or minus inverse sine of A. Right? That's my two solutions. So I have sine inverse plus 360n, because we could go around, forward, or backward 360 and get another solution, or 180 minus 360. So if my answer, if sine inverse is 30, my other answer is 150. 180 minus 30. When A is negative, then we are going to get inverse sine is going to give us this answer. Sine inverse of A is going to be right there. And this is still, down here, is still 180 minus sine inverse of A, because my sine inverse is going to be a negative angle as well. It's going to say, for example, negative 30. And so if this was negative 30 degrees, my other solution is 180 minus negative 30, or 210. And then our last set, really quickly, and then so in radians, it's instead of 180, it's pi, and instead of 360, it's 2 pi. For arctan, for inverse tangent, again, if A is positive, we are up here. There's my tan inverse of A, and then the next solution is always 180 degrees away for tangent. So down here, and I only need the one answer, because if my answer's here, I get another answer one period away, and we just keep doing our period, and for negative, right there. So I get my one answer. Here's my inverse tan. It would be a negative answer, and I can add multiples of 180 or pi depending on my mode. So let's try this out. Find the general solution, then find the answers, negative 360 to 360. So one more twist we're going to throw in here is we're going to give you some different intervals instead of just 0 to 360. So our first step is always undo outside transformations. Tangent of theta is 1 over root 3, which if you are using your triangles, you could do, or you could think in that if it was rationalized as root 3 over 3. Either way, you should recognize, oh, this is the 30-degree reference. And so right there, if I just do, so theta is tan inverse of 1 over root 3. That is one solution. And then our formula says all the other solutions are 180 degrees away. And so that right there is a general solution, and I would accept this. On a test, you could also do tan inverse. What is tan inverse of 1 over root 3? Well, this is the 30-degree reference, and so this will be 30 degrees plus 180n. That's my solution. That is the general solution right here. This represents every angle that is a solution for this equation. Now I want my angles for negative 360 to 360. So let's start with the one we know, which is 30. What this formula says is if I make n equal to 1 and I add 180, I get another solution, 210, which if you think about our picture, right, when we were coming up with just our two solutions in our head, the other solution where tangent is positive is in quadrant 3. And this is indeed 210 degrees. So now I have this. Adding 180, subtracting 180 will take me to more solutions. So I can go forward again, but if I go forward again 180, I would get to 390. Oops, too big. What I have to think about, though, is I asked for all the solutions from negative 360 to 360. So instead of going forward 180, I'm going to start going backwards. So if I take 180, or 30, sorry, and I subtract 180. So here I am at 30 degrees, and instead of going forward 180, let's go backwards 180. I'll be right there at negative 150 degrees. And if I go back another 180, you could go back 200, which would be negative 350, but then that's too far, so you could be negative 230 degrees. And there's my solutions. I'm sorry, I don't mean negative 230, I mean negative 330. Because we'd be, so here we are at negative 210. If we kept going backwards, we'd be right there at negative 330. So there's all my answers. Here's my general solution right here, and all the solutions for 0, or negative 360 to 360 are right there. All right, let's try another one. This one has a few more different kinds of transformations. So again, outside transformations first, we are going to add root 3 to both sides, which gives me 2 sine of 2 theta is root 3. Then we're going to divide by 2. So sine of 2 theta is root 3 over 2. Now I'm at the inverse sign. So now I have my 2 theta is, what are my two solutions? Sine inverse of root 3 over 2 plus 360n. Or 2 theta is 180 minus sine inverse root 3 over 2 plus 360n. And now to come up with these two, you can just figure out what your sine inverse of root 3 over 2 is and plug them into both formulas. Or you can go back to what we were thinking is, and I think at this point it's a good time to try and do your sine inverse before you do any dividing. So I'm thinking in my head, where is my sine root 3 over 2? Root 3 over 2 is the big side, so I am right there at 60 degrees. So inverse sine can be replaced with 60 degrees. So I have the answer of 60 or 180 minus 60, which if we would have drawn our picture here, we would have gotten, in either case, 120. So I know that's what 2 theta equals. So 2 theta is 60 plus 360n, or 2 theta is 120 plus 360n. That is not my general solution. I want to know what theta is, not 2 theta. So my last step here is to divide by 2. And when we divide, we have to divide everything by 2. All right, so I'm going to get theta is 30 degrees. And it should always work. If you think right now back to our original, what was the period here? My period is 360 over 2 or 180. That is always how many n, like how many n we should be adding. So I should be adding 100n when I'm done. And then if I keep going, my other answer is 120 divided by 2, which is 60 plus 180n. There are my two general solutions. I would also accept if up here you divide everything by 2 and you get theta is sine inverse root 3 over 2 plus 180n, that would be an acceptable general solution. And here I'd have to do 180 minus sine inverse of root 3 over 2 plus 180n. I would accept that as well. But I think it really, when we don't have a calculator, this right here is going to be the best solution. Now I have to think about what particular solutions do I want. And up here we are saying from 0 to 720. So I want all the answers from 0 to 720. Ooh, I think that's going to be a lot. So I'm going to start with 30, and I add 180, and I get 210, and I add 180, and I get 390, and I add 180 again, 490, and then 570. And if I add 180 again, that would be 670, and 180 is going to be too big. For my other ones, 60 plus 180 is 240, plus 180 is, let's see, 340, and 80 is 420, and another 180 will be 600 degrees. And coming up with these other solutions, it may also help to think about, here's my triangle, so I'm at 30, and I have another answer 180 later. That's 210. 180 later would be 360 plus 30, so there's my 390. And then if you know this is 540 plus 30 is 570, and so on. You can get those two sets of solutions and keep going, or my 60 and 240, and keep going around. My next one is 360 plus 60. That's the 420, and so forth. All right, let's try another one. We're going to get a little bit tougher now. We're going to go into radian mode. So we've been thinking in degrees, but we should be able to do it in radians as well. Same process. So we're going to start here. First step is to divide by 4. I have sine of x minus pi over 6 equals 1/2. And then we are going to inverse sine at this point. So x minus pi over 6 is sine inverse of 1/2 plus, in radian mode, 2 pi n, or x minus pi over 6 is sine inverse, 180. Nope, not 180. We are in radians. Pi minus sine inverse 1/2 plus 2 pi n. And again, if you are not the biggest fan of this formula, if you want to think about it in your head, you can do the same thing. It's still the same process. Where is my sine 1/2? Sine is 1/2 at 30, which is pi over 6, and over here at 150, which is 5/30s, or 5 pi over 6. So those are my two solutions. So when I can plug them in, here I have x minus pi over 6 is pi over 6 plus 2 pi n, and this would give me x minus pi over 6. I can think about it being pi minus pi over 6, which is 5 pi over 6, or just 5 pi over 6 plus 2 pi n. Now again, I am still not done. I do not have a general solution. A general solution would say x equals. So if I think about up here, how do I get x alone? I'm going to add pi over 6, or right here, it'll be easier to see that. So if I have pi over 6 and I add another pi over 6, I get 2 pi over 6, otherwise known as pi over 3, plus 2 pi n. And then down here, when I add pi over 6, because you always undo, I'm going to get 6 pi over 6, but 6 over 6 is just 1, so I would get pi plus 2 pi n. These are my general solutions. And now I have to think back. Let's take a look back. What interval do I want my answers? I want all the answers from 0 to 4 pi now. So if we go basically twice around our circle. So my first answer is pi over 3. And then I'm going to take pi over 3 and I'm going to add 2 pi. Well, I have to think about common denominators. Pi over 3 plus 2 pi. If I want it to be over 3, I need to multiply the top by 3. So I'm adding 6 pi over 3. And that would give me 7 pi over 3. And another 6 pi over 3 would be 13 pi over 3. But 2 pi, like we said, is 6 pi over 3. So or I want to get to 4 pi. Ooh, how big is 4 pi in pi over 3s? Is 12 pi over 3. So this is my max. And if I add 6 pi over 3 to 7 pi over 3, I will end up at 13 pi over 3, too big. So we're going to go to our other solution, the pi. And so pi is an answer. Then I'm going to add 2 pi to that. 3 pi is underneath 4 pi. And if I add another 2 pi, I end up at 5 pi. Definitely too big. All right. So those are my solutions. Let's try one more with a little horizontal transformation, dilation. So again, we're going to subtract our 1, divide our 2. Hopefully, by now, you are pretty good at getting here. This is very basic at this point, or it should be. If you're still having trouble with this, come in, get some help. So now I'm at the undo. When we get 2x is, in this case, with cosine, it's plus and minus cosine inverse -1 over root 2. Or this, you could also say this is negative root 2 over 2, depending on which method you like. So where is my cosine? Negative, or where is inverse cosine of -1 over root 2? It's going to be over here, and that's a 45-degree reference, which makes this 3 pi over 4. So that's my positive. And then the other answer is negative 3 pi over 4, which is over here. But negative 3 pi over 4, you might be more comfortable. And actually, since I want my answers to be from 0 to 2 pi, another possible answer is 5 pi over 4. So either one of those will work. And then, of course, I forgot my 2 pi n. So that's my 2x. And I think it helps to come up with your angles before you do your dividing. So 2x is 3 pi over 4 plus 2 pi n, or 2x is 5 pi over 4 plus 2 pi n. I really like working with positive angles if possible. So now I want to get my x. I divide everything by 2. And unlike the last thing, dividing by 2 is the same as multiplying by. I think that's going to be a little easier to see, multiplying by 1/2. And so for our first one, we're going to get x is 3 pi over 8 plus pi n. And down here on the bottom, x is 5 pi over 8 plus pi n. And if I think about, again, what I started with, the period is 2 pi over 2, which is pi. And so I should be adding multiples of pi to get more solutions. I'm adding my period. So these are my general solutions, right here and right here. Another alternate solution here could have been, if I would have used my negative 3 pi over 4, is negative 3 pi over 8 plus pi n. That would be an acceptable alternative to that, and I'm fine with that. But we have to remember, we do eventually want to get our answers, and in this case, I'm doing answers from 0 to 2 pi, which if I'm in pi over 8s, 2 pi would be 16 pi over 8, because 16 over 8 will give me 2. So I'm going to stop finding answers once I pass 16 pi over 8. So I have my 3 pi over 8. There is an answer. And I have my 5 pi over 8. There's an answer. But I want the next answer after 3 pi over 8. 3 pi over 8 plus pi, which is 8 pi over 8, is going to give me an answer of 11 pi over 8. And if I add another 8, I will be at 19 pi over 8, which is past 2 pi, 16 pi over 8. So that would be too big. 5 pi over 8 is good. If I add 8 pi over 8, 13 pi over 8 is good. It's still beneath 16 pi over 8, but another 8 would put me at 21 pi over 8, and then I am too big. So hopefully now you have enough to be able to start. You're on your own and do some problems tomorrow.